Ever wondered how computers make seemingly brilliant decisions in games like chess or tic-tac-toe? At its core, it's often thanks to an algorithm called Minimax, a deceptively simple yet powerful technique. Let's break it down. Imagine a game as a decision tree. Each node represents a possible game state, and the branches represent the possible moves. Minimax explores this tree. Max represents the player trying to maximize their score. It picks the move that leads to the highest possible evaluation. The leaf nodes here indicate the final state of each possible branch, with a numerical score. The higher the score, the better for Max. Now, Min represents the opponent, trying to minimize Max's score. It assumes your opponent will always make the best move for themselves, which is the worst for you. It chooses the path that leads to the lowest possible score from Max's perspective. That lowest score is then passed upwards. This process repeats, alternating between Max and Min at each level, working its way up from the bottom of the tree. The algorithm then selects the move at the very top, the root node, that leads to the best-case scenario, assuming the opponent always plays optimally. In practice, Minimax often uses an evaluation function to estimate the score of non-terminal game states, because exploring the entire tree to the end is computationally expensive. This helps the AI make intelligent decisions even without knowing the final outcome. So, Minimax is a game-changer, allowing AI to make strategic choices by anticipating the opponent's moves and optimizing for the best possible outcome. It's simple, yet the underlying principle behind many complex game-playing AI systems